Welcome. Next, we'll take a look at another way to measure positioning or relative standing. And it says, while there's no universal definition of percentile, in common use, when you refer to a percentile value of a data point, it indicates that a certain percentage of data falls below that value. So generally, percentiles are used with large populations, and you see them referenced frequently in education and health fields. So let me do just an example here of education example. So let's say that you are interested in attending law school, and you'll need to take the LSAT, so the law school admissions test. And a lot of people, I would assume that's a pretty large population of people taking the LSAT at any given time. And then you'd like to know how you did compared to the other test takers. So what percentiles do is they divide a data set into 100 equal parts. So if we had all the scores, we would arrange them from the lowest score all the way up to the highest score. We'd put them in numerical order. So when we're talking about measures of positioning, we need our data to be sorted. And then the percentiles would separate that data into 100 equal parts. So let me talk about this one. It says P2. So P for percentile, and then that subscript 2 would indicate the second percentile. So whatever that score is, the second percentile would tell you that about 2% of data or scores in this case would be below that value. So at the second percentile, we would know that that area below it, so this bottom 2% of scores is what would be formed. So that is the common use definition. It just tells you about P%. So for any percentile, P% of data values are less than that value. All right, so if you were taking the LSAT, you probably wouldn't want to be down here in the bottom 2%. It would be great to be up here. So let's talk about the 99th percentile. So whatever that score is, that says it would separate the top 1% from the rest. So P99. So the percentile tells you the percent of data below the value. And that means you can always figure out percent of data above. So we'll step through both of these, and let's switch to an example in a health-related field like children's growth charts. So if you have children now or in the future, you will probably become familiar with growth charts because they're a standard part of a child's checkup. So growth charts show how a child is developing compared with children of the same age and gender. So let's take a look at an example. So let's suppose that weights of 4-year-old boys are normally distributed. So when we talk about percentiles, we don't need to have bell-shaped curves, but I'm just doing an example here so you can see a visual down below of a normal distribution. All right, and I'm going to add an additional piece of information. So let's say we know that weights of 4-year-old boys are normally distributed, and let's say that the mean weight, so I tried to look up and get an idea of about what the mean weight of a 4-year-old boy in the United States would be, and I'm going to go with 36 pounds. So the mean weight is 36 pounds. Okay, so I'm going to come down to my graph here, just talk about this graph first. So in this example, my x-axis here is weight of a 4-year-old boy in pounds. And previously, we did problems where we put the mean in the center. I'm just going to write the word mean up top because we're not going to refer to that here, but that would be the mean of 36 pounds. So if we have a bell-shaped curve and we randomly pick a 4-year-old boy, most of the time we'd expect them to be around 36 pounds. All right, but let's talk about positioning then. So position-wise then, if a boy weighed 36 pounds, about half of boys would weigh less and about half would weigh more. So that 36 pounds is not only the mean, but it would be the median the middle value of the data set. All right, so the mean is at the center of a symmetric graph, and so is the median. And now in terms of percentiles, if 50% of boys weigh less, that 36 pounds is called the 50th percentile. So capital P for percentile and just a subscript there, 50. So 36 pounds at the 50th percentile means about 50% of boys weigh less. And of course, 50% weigh more. All right, so let's move over to Spencer. So Spencer is a 4-year-old boy, and he has a weight at the 10th percentile. So the percentile tells me that approximately 10% of boys his age weigh less than Spencer. So that's all you have to remember. That percentile tells you percent of data below the value, in this case, Spencer. So let me come over to this picture. So we know at the center of the graph, that's the 50th percentile. But Spencer is going to be below that at the 10th percentile. So this is where Spencer is. All right, so graphically then this shaded area would just be 10% representing 10% of boys. So again, I'm just gonna write pounds here. So about 10% of boys weigh less than Spencer. Now notice I don't even know what Spencer weighs. It's not relevant here. We're not interested in the specific value of what he weighs. We're interested in how he compares to other boys his age. So if he was in a huge group of boys at some conference, I don't know, about 10% of boys would weigh less. And then of course, if 10% weigh less, then 100% minus the 10, the other 90% of boys would weigh more. So 10th percentile says 10% weigh less, and that means approximately 90% of boys would weigh more. So I now know that Spencer here is below the median, so on the smaller side weight-wise compared to boys his age.